Hello viewers, welcome to my YouTube Anjaneya Maths channel. Myself Professor Gorpade. In today's video, we are going to study the meaning of logical equivalence of the two statement patterns and the examples based on that, and then the rules of negation for various connectives and the examples. So let us begin with logical equivalence. The two statement patterns A and B are said to be logically equivalent if their truth tables are identical. The truth tables of statement A and statement B are identical, then we can say that the two statement pattern A and B are logically equivalent. Or if they have the same truth values in their respective columns in their combined truth table is known as the logical equivalent. It is denoted by A is equivalent to B. Now, by referring this definition, we are going to work out the examples based on the logical equivalent. The questions like this, using the truth tables, prove the following logical equivalencies. So the example is negation of P conjunction Q is logically equivalent to P disjunction Q conjunction negation of P. Now left hand side one statement pattern is there, and on the right hand side one statement pattern is there. So we have to show that these two statement patterns are what are logically equivalent. We are going to show that the truth values of both the statement patterns are what are identical. The truth value of P is TTFF, truth value of Q TF. The negation of P, so negation of P is F, negation of T is F, whereas negation of FF is what T and T. Then you have to take the conjunction between negation of P and Q. So conjunction between these two columns. The conjunction is true if both are true and it falls in all other cases. So T of F conjunction F is F, T conjunction T is T, F conjunction T is what? F. Then come to the next column, which is nothing but the disjunction between P and Q. So the disjunction is true if both are true, or if any one of the two statement is true. Then let us take the disjunction TT T, TF T, FT T, FF F. Then you have to take the conjunction between these two columns. So the conjunction is true if both are true, and in all other cases it is false. So F conjunction T is F, F conjunction T is F, T conjunction T is T, T conjunction F is F. Now we observe the truth values of the statement pattern negation of P conjunction Q is present in column number 4, whereas the truth values of the right hand side is present in column number 6. Now we try to identify the corresponding truth values. So first here F, F, here F, F, here T, here also T, here F, here also F. That means the corresponding truth values in the two columns, column number 4 and 6, they are what? Identical. So from columns 4 and 6 we have negation of P conjunction Q is logically equivalent to P disjunction Q conjunction negation of Q. So in this way you have to prove the given two statement patterns are what are logically equivalent. Take the next example. Negation of P disjunction Q, disjunction, negation of P conjunction Q. This is one statement pattern, is logically equivalent to negation of P. This is the second statement pattern. So we have to show that these two statement patterns are what are logically equivalent. say the truth value of P is TTFF, truth value of Q is TF, then negation of P is, negation of T is F, negation of T is F, negation of F is T, negation of F is T. Then the disjunction between P and Q. So the disjunction is true if any one of the two statements is true or both are true, and it falls in all of the cases. So T disjunction T is T, T disjunction F is T, F disjunction T is T, F disjunction F is F. Then next is what? Negation of this column. So negation of T is F, negation of T is F, negation of T is F, whereas negation of F is what? T. Then take negation of P conjunction Q. Negation of P conjunction Q. So this is negation and this is Q. In between the column number 3 and 2, the conjunction is there. The conjunction is true if both are true, and it falls in all other cases. So the conjunction between negation of P and Q. So F conjunction T is F, F conjunction F is F, T conjunction T is T, T conjunction F is F. Then take the left hand side statement pattern. In between these two, the disjunction is there. So the disjunction between the column number 5 and 6. So the disjunction is true if both are true or any one of the two statements is true. So F disjunction F is F, F disjunction F is F, F disjunction T is T, T disjunction F is T. So the column number 7 gives the truth values of the left hand side statement pattern. The right hand side statement pattern is what? Negation of P. So which is nothing but the negation of column number 1. So F F T T. So if you observe the truth values of the left hand side statement pattern, that is column number 7, and the truth value of right hand side statement pattern, column number 8. If you see the corresponding truth values, they are what? Identical. They are same. F F F F T T T T. That means what? What it indicates? It shows that the two statement patterns are what? Logically equivalent. From columns 7 and 8, we have, so negation of P disjunction Q, disjunction, negation of P conjunction Q is logically equivalent to negation of P. This is the proof. Take the next example. P biconditional Q is logically equivalent to negation of P disjunction Q, conjunction, negation of P conjunction Q. First take the truth value of P, that is T T F F. Then truth value of Q, T F T F. Then you find the truth value of the left hand side statement pattern, P biconditional Q. Biconditional is true if both are true or both are false, and it falls in all other cases. So T T T, T F F, F T F, and F F T. Then come to the right hand side. First is what? P disjunction Q. The disjunction is true if both are true or if any one of the two statements is true. So that is disjunction between this P and Q. T T T, T F T, F T T, F F F. Then take the conjunction between P and Q. The conjunction is true if both are true, and it falls in all the cases. So T conjunction T is T, T F F, F T F, F F F. Then we take the negation of this P conjunction Q. So negation of T is F, negation of F is T, negation of F is T, and negation of F is a T. Then in between these two, conjunction is there. So the conjunction between what? Conjunction between column number 4, P disjunction Q, and the negation of P conjunction Q, that is column number 6. So the conjunction is true if both are true, and it falls in all the cases. So T conjunction F is F, T conjunction T is T, T conjunction T is T, and F conjunction T is what? F. Then finally what? The negation of these two. Negation of the statement pattern P disjunction Q, conjunction, negation of P conjunction Q. So the negation of F is T, T is F, T is F, F is T. Now this column number 8 is the right hand side statement pattern, and column number 3 is what? A left hand side statement pattern. Now we observe their truth values. The corresponding truth value should be identical. So first is T, here T, here F, here it is also F, then next is F, here also F, and last one is T, here also the last one is the T. That means the corresponding truth values of the left hand side statement pattern and the right hand side statement pattern are what? They are identical. So from columns 3 and 8 we have, so P by conditional Q is logically equivalent to negation of P disjunction Q conjunction negation of P conjunction Q. So this is the proof of this. Take the next example. P disjunction Q implication R is logically equivalent to P implication R conjunction Q implication R. So in a given statement pattern, 3 statement letters are present, P, Q and R. If the 3 statement letters are present, then each statement letter consisting of 8 truth values. So for the statement letter P, first 4 are true, next 4 are false. Statement letter Q, first 2 are true, next 2 are false. Like that alternatively you have to write till the 8 truth values. For the statement letter R, first is true, second is false, true, false. Like that alternatively write till the 8 truth values. In the left hand side, the statement pattern which is present is P disjunction Q conditional R. First work out this P disjunction Q. The disjunction is true if both are true or any one of the two statements is true. So the disjunction between P and Q, T, 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 T of T, T of T, F, T, T, F, T, T, F, 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 F. So this is the disjunction between P and Q. Then with this, you have to take the implication with the R. Now P disjunction Q to R. So while writing the truth values of implication, the order is more important. Now you have to take from P disjunction Q to R, like this you have to take Q to R. T, 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 T of F, T, T, it is T, T of F, F, T, T, F, F, T, F, T, T, F, F, T. Implication between Q and R, Q to R. So T, 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 T of F, F, T, T, F, F, T, 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 T of F, F, T, T, F, F, T. Then finally the conjunction between these two statement patterns. So the conjunction is true if both are true and it falls in all the cases. So T conjunction T is T, F, 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 T, 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 F, T, F, T, 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 T of F, T, T, T and T, T, T. Now we have obtained the truth values of the statement pattern of the left hand side as well as the statement pattern of the right hand side. So the left hand side is present in column number 5 and the right hand side is present in the column number 8. So we try to identify the corresponding truth values of these two columns. So first is T, next is F, next is T, next is F, again it is T. So F, T, T means what? The corresponding truth values of left hand side pattern and the right hand side statement pattern are what? Identical. So from columns 5 and 8 we have P disjunction Q implication R is logically equivalent to P implication R conjunction Q implication R. So this is the proof of the given logically statement pattern. Next is what? Negation of compound statements. See, if P and Q are any two statements, then their disjunction is denoted by what? P disjunction Q, like this. Then the negation of P disjunction Q is negation of P conjunction negation of Q. Means what? while taking the negation of the disjunction of P and Q, the disjunction changes to what? A conjunction. And you have to take the negation of each statement. So negation of P and negation of Q. So negation of P disjunction Q is logically equivalent to negation of P conjunction negation of Q. Then if P and Q are any two statements, then their conjunction is denoted by a P conjunction Q. So the negation of P conjunction Q is logically equivalent to negation of P disjunction negation of Q. So while taking the negation of conjunction, the conjunction changes to what? A disjunction. And you have to take the negation of each statement. So negation of P, negation Q. So negation of P conjunction Q is logically equivalent to negation of P disjunction negation of Q. Then if P and Q are any two statements, then their conditional statement is denoted by what? P implication Q. So the negation of P implication Q is given by P conjunction negation of Q. Then biconditional, if P and Q are any two statements, then their biconditional is denoted by P both side arrow mark Q. So the negation of this P biconditional Q is logically equivalent to P conjunction negation of Q or disjunction Q conjunction negation of P. So these are the rules of a negation of compound statements. Even we can prove these rules by using the truth table also. So let us take first. So we can prove these negations even by using the truth tables also. Say the negation of P disjunction Q equal to negation of P conjunction negation of Q. So in the left hand side statement pattern is what? Negation of P disjunction Q. So P Q whose truth values are T T F F T F T F. Then negation of P F F T T, negation of Q F T F T. Then take the disjunction between P and Q. Disjunction is true if both are true or any one of the two statement is true. T T T, T F T, F T T, and F F F. Then its negation. So negation of T is F, T is F, T is F, and F is a T. Then the right hand side statement pattern is what? Conjunction between negation of P and Q. So take the conjunction between these two columns. The conjunction is true if both are true and it falls in all of the cases. So F conjunction F is F, F T F, T F F, and even T T T. Negation of P conjunction negation of Q is what? T. So now you observe the truth values of column number 6 left hand side statement pattern, column number 7 right hand side statement pattern. Their corresponding truth values are what? Identical. So we can say that negation of P disjunction Q is logically equivalent to negation of P conjunction negation of Q. Therefore, this is the rule. The rule is important for the rule of negation of compound statement. So negation of P disjunction Q is logically equivalent to negation of P conjunction negation of Q. Right? So like that we can prove even these negations by using the truth tables. Take the example. The question is like this. Write the negations of following compound statements. So the first example, some roses are red and all lilies are white. So this is a compound statement which is a combination of two statements. The two statements are combined by using the connective AND. So to write the negation of these compound statement, first we represent in a symbolic form. So first of all, I will take the first statement as P, some roses are red. Second statement as Q, all lilies are white. So the given statement is, which is into its symbolic form, is what? A P conjunction Q. Now by using the rule of negation of P conjunction Q is logically equal to negation of P disjunction negation of Q. So this law is also known as what? De Morgan's law. So the negation of the given statement, first negation of P. P is what? Some roses are red, its negation. Some roses are not red. Then the conjunction changes to what? Disjunction or. Then negation of Q. Q is what? All lilies are white. Its negation, all lilies are not white. So this is the negation of the given compound statement. Take the next example. If n is an even integer, then 2n is divisible by out of 4. So this is the compound statement. What type of connective is used? If then conditional statement it is. So let us take the first statement P. N is an even integer. Then Q, 2n is divisible by out of 4. Then the given statement pattern can be written into its symbolic form as out of P conditional Q. Then by using the rule of negation, negation of P conditional Q is equivalent to P conjunction negation of Q. So negation of the given statement is, so first P, what is P? N is an even integer, N is an even integer. Then conjunction and, so and negation of Q. Q is what? 2n is divisible by 4. Its negation, 2 is not divisible by 4. Not and. So conjunction and, negation not. So this is the negation of the given compound statement. Take the next example. Horses have wings if and only if men have tails. So this is the compound statement, the connective which is used is what? If and only if. Biconditional statement it is. So let us bifurcate the compound statement into the two simple statements. Statement P, horses have wings. I will take Q as a men have tails. So the given statement pattern into its symbolic form is what? P biconditional Q. Now by using the rules of negation, negation of P biconditional Q is P conjunction negation of Q, disjunction Q conjunction negation of P. So take P, P is horses have wings, horses have wings, then conjunction and, or you may use instead of and but also you can use and but, negation of Q. Q is what? Men have tails. Its negation, men do not have tails. So this is this one. Then disjunction or Q. Q is what? Men have tails. Conjunction and, or you may use but, negation of P. Horses do not have wings. So this is the negation of the given compound statement pattern. Take the next example. It is night or all the stars are shining. So again it is a compound statement which is a combination of two simple statements by using the connective or. So take the first simple statement as P, it is night. Then statement Q, all the stars are shining. So we represent the given compound statement into its symbolic form. So as a P disjunction Q, P or Q. Then by using the rule of negation, negation of P disjunction Q is negation of P conjunction negation of Q, which is nothing but this rule is also known as the De Morgan's law. So according to this, the negation of the statement is negation of P. So P is what? It is night. Its negation, it is not night. Conjunction and negation of Q. Q is what? All the stars are shining. Its negation, all the stars are not shining. It is not night and all the stars are not shining. So this is the negation of the given compound statement. Now the next question is like this. Using the rules of negation, write the negation of the following statements. First example, P conjunction negation of Q conjunction R. So, which is nothing but the combination of what? Conjunction of the two statements. This is in the form of what? A conjunction B. Then what is this rule? So negation of A conjunction B is what? Negation of A, disjunction negation of B. So therefore negation of P conjunction negation of Q conjunction R is equal to negation of P disjunction negation of Q conjunction R. So De Morgan's law. So that is negation of P disjunction. This is in the form of what? Negation of statement P is always equal to what? The statement P only. Means what will get here? We will get Q conjunction R. So this is the negation of the given statement P conjunction negation of Q conjunction R. Take the next example. Negation of P disjunction Q condition negation of R. Again, this is in the form of what? Disjunction of two statements. This is one statement, this is second statement. So by using the rule of negation of disjunction, so negation of A, disjunction changes to conjunction, negation of B. That is nothing but De Morgan's law. So therefore negation of P disjunction Q implication negation of R is logically equivalent to negation of the first, that is negation of P, disjunction changes to conjunction, and the negation of the second, negation of Q implication negation of R. So De Morgan's law. So negation of P is P conjunction. Now negation of a conditional statement. So what is the negation of the conditional statement? So negation of P implies Q gives P conjunction negation of the second statement. By using this can be written as, so Q conjunction negation of R, that is P conjunction Q conjunction negation of R is what? R. So this is the negation of the given statement. So the next example is negation of P disjunction negation of Q conjunction P conjunction negation of Q. That is the one. Again it is what? The conjunction between the two statements, say A and B. So the conjunction, if you take the negation of A conjunction B, this is what? Conjunction changes to disjunction in order to write the negation of each statement. Negation of A, negation of B. That is nothing but De Morgan's law. So therefore negation of the given statement, negation of P disjunction negation of Q conjunction P conjunction negation of Q is negation of the first statement, means what? Negation of P disjunction negation of Q. That conjunction changes to what? Disjunction, and a negation of the second. So P conjunction negation of Q. So De Morgan's law. De Morgan's law. So that is Now again by using the De Morgan's law, you have to take the disjunction of the negation of this, disjunction of the two statements. So negation of P, disjunction changes to conjunction. So negation of Q, then disjunction, negation of P, conjunction, negation of Q. So negation of P, conjunction changes to disjunction, and negation of Q. So again by De Morgan's law. So that is negation of P is P, conjunction, negation of Q is Q, disjunction, negation of P, disjunction, negation of Q is Q. So this is the negation of the given compound statement. So this is regarding the logical equivalence of the two statements and the rules of the negation of the various connectives. If you feel that this video is useful for you, then you please like it, share it, and subscribe it.